These are transformation questions in complex numbers, also sometimes called DOTS questions. So this is an example from 2023. So the earlier part of the question was straightforward enough, but some people found this one tough. It certainly takes practice for a lot of people to get their head around it. It says the Argand diagram below shows the complex number u is equal to a plus bi. So a units out on the real axis, b units up on the imaginary axis. It says write the complex numbers I times u, and remembering of course that u is equal to the a plus bi, and then the conjugate of I times u in their simplest forms in terms of a and b, where I u conjugate is the complex number, the complex conjugate of iu. Okay, so what I often suggest to people who are really find this tricky is that you add in some units. So let me just click here that you'll see here in a moment, right, that if we multiply I times u, as we're instructed to and directed to down here, well, I times u would be I times a plus bi, so it's ai plus bi squared. We know that I squared equals minus 1, of course, so that gives us minus b plus ai. So that's my point. Now, some students will say, well, how do I draw that? Okay, so I will go through the conjugate as well. So the bar means conjugate. So what do you do when you're going from a complex number to its conjugate? You just change the sign in between the real part and the imaginary part. So in this case, I times u was minus b plus ai, so I times u conjugate is minus b minus ai. Okay, so in this case we were a units to the right on the real axis and b units up on the imaginary axis. Now, what I suggest to students who do really find this a bit awkward is that if you try putting in units, so you won't always get this fully right, but we'll say that's 1 unit there, and then if we go up, it doesn't say they're on the same scale here, which makes it a bit arbitrary, but I could say that that'd be 4 units up, so I, 2i, 3i, 4i, and that would make my point 1 plus 4i. So then if I think about multiplying that by I, so I times 1 plus 4i, well, I followed the same process here, and I get I times 1 is I plus 4i squared. I squared is minus 1. Minus 1 times 4 would be minus 4. So I get minus 4 plus I. Now, where would that point be? Well, where it would be was right here. You'll see the point here now in 1 second. It'll be here. Because again, this would be minus 1, minus 2, minus 3, minus 4. And up above it then, this would be, 1 unit or 1i. So for some people they find that easier. I'll go through the visual of it in a moment when you can see it as a transformation as well. The last part then is the I times u bar or iu conjugate. So we have minus b minus ai. So in my case here, if I put in my values, I times u is equal to minus 4 plus I. So iu conjugate would be minus 4 minus I, which would obviously be directly below it. So it's an axial symmetry through the real axis. And in my case here, this would be the point minus 4 plus I, and this would be the point minus 4 minus I. Now, I can of course look at that without any of these kind of coordinates in there or anything like that. And of course I can do that too, and I'm going to show you how you do that now in the next part, because it asks us to plot them and label them as accurately as possible, okay? And then it says state what transformation or series of transformations would send u to iu. And it says do not include a translation in your answer. So in this case, what they're saying is they want this key bit of information, this key bit of knowledge, that if you ever multiply a complex number by its conjugate, but if you ever multiply a complex number by I should say, it rotates the point 90 degrees anti-clockwise about the origin. So it's a 90-degree rotation anti-clockwise about the origin. Now some people can see that so clearly, it makes so much sense to them, and other people, just prefer to have the numbers in there so they can have a bit of clarity on it. Then the second part, to go from IU to IU bar, IU conjugate, is the conjugate is then the reflection in the real axis, or an axial symmetry of the point through the real axis. So in common sense, or how it looks, is you go down to the real axis at 90 degrees and out the same distance the far side. So some students, and our students who have practiced it a lot, can find that very straightforward, and others find it the most difficult part of the whole thing. It came up in 2014 in the sample paper as well. It came up a lot of time in pre-exams between now and then, but not really in the exam itself. So it was certainly due. This was the question from the pre-exam, or from the sample paper back in 2014. It was there in previous years' sample papers as well. But it says 4 complex numbers Z1, Z2, Z3, Z4 are shown in the Argand diagram. They satisfy the following conditions. Z2 is I times Z1. Z3 is K times Z1. Z4 is Z2 plus Z3. So I'm going to do this in 2 ways again. Firstly, I'll go through it this time we'll just say using logic, or using visual first, and using my knowledge of the rules. I know that Z2 is I times Z1. And going from the previous part, I know that when I multiply a complex number by I get an anti-clockwise rotation 90 degrees about the origin. So sometimes you got to do a kind of trial and error with this to get your head around it. So maybe you'd say, okay, could that one on the left be Z1? Could the one over there on the right be Z2, because we know it's a right angle? But then when you think about it, you'd say, no, that can't be true. This guy must be Z1. This guy must be Z2, because it's an anti-clockwise rotation about the origin. Now, why I'm sure it has to be those 2 points is because they are the same distance from the origin. So once you multiply Z1 times I, you get Z2. The distance to the origin is the same. You are in a different quadrant. You've rotated 90 degrees anti-clockwise. The other reason you can be sure that this one must be Z1 is because Z3 is equal to K times Z1. Now K is called a scalar. It's an element of the real numbers. When you multiply any complex number by a scalar, the resulting point is either further away or closer to the origin, but it is collinear. In this case, Z1, Z3 and the origin 0 plus 0i are collinear. So it either moves it further out or brings it further back, closer to the origin. So in this case, Z3 and Z1 are the only points which are collinear with the origin. So therefore, this guy here has to be Z1. Now it makes sense that this is Z4 as well, because I'm adding Z2 and Z3. If you think about the imaginary parts are both positive. So when you add the 2 positive parts, the 2 positive imaginary parts of Z2 and Z3, you're going to go even further up in the imaginary. Z2 has a negative real part, Z3 has a positive real part. You can see that Z2 is further to the left than Z3 is to the right. So therefore you will end up with a negative imaginary part, or negative real part I should say, when you put them together. Okay, so that is our answer for that part. It asks us then as well to write down the approximate value for K, and the approximate value for K, because of the fact that the distance of the origin to Z3 is, roughly speaking, looks like it's half the distance from the origin to Z1, I can say that the value there of K is a half. That the value of K is a half. Now what I'm going to try to do, because I imagine some of you are looking at it going, God, that's tricky, I don't get that. Again, what I would recommend to students in that boat is you try adding in kind of, I suppose, points, your values. Now you won't always get it fully right, but let's give it a go. I'm going to say this is going to be 1, 2, 3, 4, 5, 6 coming out here. So 1, 2, 3, 4, 5, 6. And remember, you'd have a ruler inside in the exam. So, you know, I'm going to say then this would be -1, -2, -3, -4. I'm going to go upwards now on the imaginary axis. So I'm going to go 1, 2, and remember it would be I, 2i, 3i, 4i, 5i, 6i, 7i, and 8i. And so now if I think about these points, right? If I start off and I said, if I start off my Z1, so using my values here, I'd have Z1 equals 6 plus 4i. Z2 would be I times Z1. So I get 6i plus 4i squared. So I squared is -1, so I get -4 plus 6i. So that looks right, -4 plus 6i. Then Z3 is equal to, well, we figured that the k was a half, so a half times 6 plus 4i will be 3 plus 2i, and that's right, 3 plus 2i. And then Z4 is equal to Z2, which is -4 plus 6i, plus Z3, which is 3 plus 2i. It's -1 plus 8i. And that is my point up there. -1 plus 8i. So -1 plus 8i. Okay, I hope that helps you with those type of questions. There's a lot of them there in the old pre-exams. If you practice enough of them, they can become easy. You can trust me, you mightn't believe me yet, but practice enough and it'll happen.